Alright, in today's lesson, we are talking about calculus, that is, derivatives of exponential function. A function that looks like this, y equal to a raised to power x. So this a is the base. The power here is a function, that is why it is called exponential function. Okay? A is constant, which is base. The same thing here, 2 is base, and is a constant, but the power has a function which is x, a variable. Same here, 5 raised to power. So only if you have a function whose base is constant and the power is a function, you know that it is an exponential function. So to differentiate this, all we need to do is let's use this, which is marginal y is equal to a raised to power x. So you take e of both sides. E means log. We have log e, log this e is something as e. So take note of it. Yeah, y is equal to a raised to power x. So take in of both sides. Okay? So in y equal to in a raised to power x. This x will come down. Okay? In y will give us x dot in a. This function here is just similar to 2a, 2x, where 2 is a constant. So every here is a constant. In a is a constant. Then x is a variable. So a constant multiplied by a variable, okay, is a term. So if we are asked to differentiate in y, you must include the y dx. Okay, when differentiating this, you include the y dx into bracket 1 all over y. That is the routine on how to differentiate this. But if you're differentiating in x, for example, you're differentiating in x, you don't include the y dx. You will say dx dx 1 over x. That dx dx will cancel out. But you are differentiating in y. You have dy dx. So 1 over y and the y over x will remain. You come over here, differentiating x dot in a means you are differentiating s, keeping this constant. So if you differentiate s, you get 1. Okay? So 1 times in a, you have in a. So I'm done differentiating this. I'm done differentiating this. Our result is going to show that making dy dx the subject of the formula, that's what we're looking for, is equal to cross and multiply. Y we multiply in a, you have y in a. Okay? So that it implies that the y, the x is equal to what is y? We took y to the what? A raised to power x. You have a raised to power x in a. Okay? So this is how we differentiate this function, exponential function. So let's see how we can do this, and do any subsequent ones. Even when you have y equal to 2 raised to power x, what will you do? Take the in of both sides, and y is equal to 2 raised to power x. X will come down, implies that y is equal to x in 2. Implies that, so differentiating this, as I said before, you have to y dx into 1 over y is equal to 2. If you differentiate x, you get 1. So making the y dx the subject of the formula, you have y and 2, which in turns says that the y dx is equal to, what is y here? 2 raised to power x and 2. Okay, let's look at the shortcut. There is a note for the shortcut. Y is equal to 5 raised to power x. Answer, divide the x is equal to, take down the question, 5 raised to power x in 5. Okay?